Jurassic Park has just reopened and needs an advanced energy vehicle to traverse a monorail in the park. The vehicle must start at Station 1, the visitor center, and go to the entrance gate, then wait 7 seconds for the gate to raise. Then move to Station 3 and pick up the caboose. After picking up the caboose, the vehicle will travel back to the gate, wait another 7 seconds, then go back to the visitor center. The goal is to minimize energy to mass ratio while maintaining operational consistency. This must be completed within 2.5 minutes. The AEV can only have 1 to 3 motors and must fit into a storage box without the rail mount. The Arduino must have 2 inches from the magnet and can't be placed on the rail mount. Also, it cannot touch any metal.
My design for Ducky was based on the Jurassic Park theme that we were given at the beginning of the project. I tried to replicate the body style and head style of a pterodactyl while still maintaining the basic AEV shape as it has to hang from a monorail.
When coming up with my design for the AEV, the goal was to create something that was aerodynamic, light, and affordable. Thus, designed it with a cone-shaped head to help with aerodynamics and use as little parts as possible to keep it light.
Since sketch is enhanced design, taking balance into consideration, I think a T-shaped arm is better than L-shaped arm. Also, in order to decrease weight of AEV, I choose X-shape as the base of my design. In this project, we finished several tests to refine our designs and programming strategies. With the help of analysis tool, it's convenient for us to make plots to analyze our data, such as these 2 plots. These 2 plots are from performance test 1. The left one describes the performance of New Ducky and another one describes the performance of PG. Comparison these 2 plots, we can find PG consumed more energy and run less efficiently. So finally we choose New Ducky as our final design.
During the making of AEV, there are several obstacles that we have faced, one of which is that our AEV rarely goes the amount of marks that it should. We think that this is because previous data is affecting how far it will go, and so we tried deleting it off before each run. This seems to have worked, but still our AEV goes the incorrect amount of marks, and so we have to fiddle with it to make it go the amount of marks that it should. The other obstacle we faced was that after creating the final design, our battery does not fit very well on where it's supposed to. To overcome this, we decided to tape it on to the supporting arm. To create our final design, we used the XP shape and had it so that way the 2 short arms are facing left and right, and 2 longer arms are facing forward and back. Then we attached the Arduino board towards the center of the X shape. After securing that down with screws and bolts, we then added the 2 motors and motor brackets, so that way the 2 motors are facing towards the front of the AEV, opposite of the direction that it will be going when it first starts. After securing those, we added 3 brackets, 2 that are facing towards the left and 1 that are facing towards the back of the AEV. The one is so that way the trolley has something to connect to when we go to pick it up. The other 2 are to attach the L-shaped lever arm. This arm is offset from the center to accommodate the battery and have it better balanced. Then the 2 sensors are zip tied on to the lever arms, so that way they catch a reflection of the 2 wheels that are then added on to the right side. After this, the battery is then taped on to the base of the lever arm each day that we run it.
This project helped us develop as engineers in several ways. We had to use creative thinking to come up with designs for our AEV, and we also had to come up with different codes to try to come up with a more energy efficient run for the AEV. Additionally, we had used problem-solving skills in order to troubleshoot problems with our code when we were testing the AEV on the track. Lastly, this project helped us improve our skills with SolidWorks as we had to build our AEVs within the program. In conclusion, we used our knowledge of coding and basic construction to build an advanced energy vehicle. This project not only taught us how to use SolidWorks and how to code mechanisms, but made us better engineers in general.